Okay, welcome back guys. We're going to be solving another question from the chapter 3 of Meriam textbook, question 23, and we have this 80 kilogram exerciser that is beginning to execute some slow steady bicep curls, and we have the tension T that is 65 newtons, and it's developed against an exercise machine which we cannot see, and we need to determine the normal reaction forces at the feet A and B, and friction is sufficient to prevent slipping, and the exerciser maintains the position shown with center of mass G. So we are in equilibrium condition, so we have the sum of all forces equals 0, and we have sum of all moments equals 0. And let's start with the free body diagram. I'm going to show it on this figure that we have. So we have the normal force at point A, where we call it NA, and we have same thing at B. So these are two unknowns that we have to figure out in this question. And if we want to dissolve the T in X and Y components, let's call this one our X, which will be T times cosine of 20 degrees, and here we have the Y component, or T sine of 20 degrees. So if we look at this, so we obviously have more forces at point A and B, which are the frictions in order to avoid slipping off the exerciser. So basically we have two frictions that are in the opposite direction of the movement. So by doing that, the feet of these exercises is going to go to the right. So our friction has to be in the opposite direction to avoid that. So since the feet are going to move toward the right, this will be the direction for the friction to the left, which is preventing the movement of the exercises. But that's not what the question is asking, and we don't need to focus on the friction in this question. The other force that we have is the weight of this exerciser, which we can call it W, which will be mass times acceleration of gravity. We know G is 9.81 meter per square second, and here we will have 80 times 9.81. That's pretty much it. Let's just do the moment about either point A or B. Let's do for point A. That way we can get rid of the unknown that we have at point A, and we have the moment of NB, as we can see, is counterclockwise, so we have a positive moment NB times distance from A to B, which is basically what we have from here to here, 250 plus 250 plus 250 millimeter. We don't need to do the unit conversion millimeter to meter because it's going to be cancelled out at the end. So let's just keep it the way it is, and we have also the moment of the weight, and as we can see, this is a clockwise direction, so negative, so minus 80 times 9.81, and the distance would be simply what we have from here to here, which is 250. And we also have the moment of the T. Let's go with the T cosine of 20 degrees. We can see that this one about point A is also clockwise, so negative, so minus T, and we know T is 65, so 65 cosine of 20 degrees times the distance that we have is, this is the line of action, this is the distance that we need, which is 1550, and the last one is the T sine of 20. This is going to make a counterclockwise moment about point A, so we have a positive 65 sine of 20 degrees, and the distance that we have is distance from here to here, which is 250 plus 250 plus 350, and that's pretty much everything. This will be equal to 0 since we are in equilibrium. There is only one unknown in here, which is NB, and if we calculate NB in here, we're gonna get 543.9 newtons, and this is one of the unknowns. And we just need to do sum of all forces in Y direction, and with that we can just find the NA. So basically we have NA minus NB, which plus NB, which is 543.9 minus the weight 80 times 9.81, and also we have the Y component of the T, which is T times sine of 20, so it's upward, plus T is 65 sine of 20 degrees. Again, we are in equilibrium. This will be equal to 0, and that's the other unknown that we have in here, or NA, and that's going to give us 218.7 newtons. And the final answer for this question, and the two normal forces that we have at point A and B. So yeah, Hope you guys find this one helpful. Let me know if you have any questions regarding this one or the 3 textbooks that we're covering in the channel. Don't forget to subscribe to the channel, like and comment. It's going to help me to reach out to more students. And you guys take care. I'll see you in the next video. Have a good one.